The digits of the positive integer n include no 9s, exactly 4 8s, exactly 3 7s, exactly 2 6s, and some other digits. If the sum of the digits of n is 104, and the sum of the digits of 2n is 100, then the number of times that the digit 5 occurs in n is. Well, n is some number. It's got 4 8s, 3 7s, 2 6, and then a bunch of other digits. I have no idea what those digits are. But they tell me that the sum of the digits is 104. Well, so far, what is the sum of the digits? We got 4 8s, so that's 32. 3 7s, that's 21. We got 2 6s, so 6 plus 6 is 12. And then some other digits, and I'll just represent that as x, that the sum of those other digits. And they're saying all that equals 104. So that means if I do the math here, x has got to be 39. So that means these guys, whatever these numbers are, add up to 39. Okay, a lot of ways of doing that. So where do you even begin? Well, this is one of those questions. It's number 25. You're down to the wire. You got like 3 minutes. Now, how are you going to do this? Are you going to use a scientific method that takes 25 minutes, or are you going to use some brute force trial and error? I'm going to use the brute force trial and error. So here we go. I looked at the answer choices. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. Those are my possible. So I'm going to say, you know what? Let's start with a possibility. They want me to figure out how many 5s occur in this group. So let's go right down the middle and see if 2 works. So I've got 2 5s in here. 5, 5. That means the other numbers have to add up to 29, because 5 plus 5 is 10. So that means the other digits have to add up to 29. Okay, let's make a list. How can I do that? Well, I can put 4, 4, 4, lots of ways, right? 3, 3, 3, 3, 3, and a 2. This is going to be 29, right? This is 12, 15, that's 27, plus 2 is 29. Okay, and let's just say it's in order like this, that n is this number, exactly in that order. Okay, so n is basically this number right here, 888, and so on. And the sum of the digits is 104. Okay, I chose these digits to perfectly match up to 104. But now I'm interested in 2n. Okay, well, you obviously can't put this in a calculator, but you guys can do this, right? It's not hard. Multiplying by 2, 6, 6, 6, 6, 6, 8, 8, 8. Okay, but now you got a 5, so there's going to be a 0. So this is going to be 0, 1. 3, 3, 5, 5, 5, 7, 7, 7, 7, 7, and then a 1. So that is my wavy 2n. And the good news is that you can actually do this in a calculator. This part you can do on your own. You certainly don't need a calculator to multiply those numbers by 2. But if you're a bit confused about this section, you can put those in the calculator. Most calculators will go up to that many digits. Okay, so now I got to add up the sum of the digits of this guy. And when I do, I get 109. Okay, well, that was a bust, because 2n has to be 100. No problem. It's a lot quicker to do trial and error, in my opinion, on this question. So let's keep going. Now, you got some good luck or bad luck here. You can either go in this direction, or you can go in either this direction. I already tried 2 5s, and that didn't work. So I'm going to go in this direction. All right, so that means I'm going to choose an n that has 3 5s. Okay, so instead of 5, 5, I'm going to choose 5, 5, 5. That means the other numbers can be pretty much the same, like this. But I've got to make sure that one of the 3's becomes a 2, right? Because I went up, so I've got to go down to match it. Okay, so now I've got a different scenario here. This time I've got an n that's slightly different. And that sum is 104. Okay, now let's figure out my 2n. My 2n, like I said, initially it's pretty easy to figure out what is 2n. not too hard to multiply those guys by 2. But then this guy, even if you don't want to do it, you can just put it in your calculator. Like if you didn't want to do it manually, you can just put it in your calculator, and that's the good part. So most calculators will go up to that many digits. So it's going to be 0, 1, 1, 3, 3, and then 5, 5, 5, and then 4 sevens, and then a 1. Okay, so another wavy, I don't know why I keep writing it in a wavy way, but that doesn't matter. Now, what is the sum of the digits of this guy? The answer is 100. So you see how it worked out pretty quickly? And it makes perfect sense too. For number 25, which is, usually the hardest or one of the hardest questions, it works out. A lot of it is just trial and error. So the answer to this question is 3 5s, because they're asking how many 5s occur in the original n, the number of times that 5 occurs in n. Well, this is my n, and through trial and error I found that if I put 5 3 times, it ends up to have a sum of 100 when I take 2n. So in a non-scientific way, we found the answer to this question, which is 3 for number 25. Therefore, that is choice D. Suppose that n is equal to 1 plus 11 plus 101 plus 1001 plus 10001, all the way till you get to this big long number, which has 50 zeros in it and 1 on opposite ends of the number. When n is calculated and written as a single integer, the sum of its digits is. So what I'm going to do is I'm going to write out these numbers sort of one on top of another, kind of like the way you learned addition when you were in grade 1 or kindergarten. So the first one is this guy right here. So just how they put it, I'll just say 50 zeros. And then the next one that's a little bit smaller will look like this, right? It will be like that. And then similarly, the next one that's 1 digit less will look like this, correct? And so on. You get the point. And then eventually I'll skip a whole bunch, ... and I'll just write 10001, these guys that they just gave me, 5 of those, right? So 1001, 101, 11, and finally 1. And then at the very end, I will figure out the sum. And that sum is that single integer. Okay, so first and foremost, how many digits do each of these numbers have? That's going to be very important. Well, this guy right here has 52 digits. How do I know that? Well, there's 50 zeros, but then we've got a 1 on either side. So 50 zeros plus 2 ones, 52. This one has 51 digits because it's just 1 digit less. And so on. You get the point. 50 digits, 49 digits. And then these ones, you can just count them. 5, 4, 3, 2, 1. Okay. Now we add these just like how you would back in the early days of elementary school. So that is all ones. Now how many ones are there? 52, because these numbers, there's 52 of them. You can clearly see that. So I've got 52 ones. So 52 ones is 52. So the 2 goes here, carry the 5. Okay. Then now I have to add this column. Well, there's only a 5 and a 1, so that's a 6. Then I have to add this column. There's only 1, so that's going to be a 1. Add this column, again, only 1, 1. And it just keeps on going like that. Every column will be a whole bunch of zeros and then just 1, 1. 1, 1, 1, 1, like that. So this is my final integer. This final integer essentially is going to be 52 digits, right? And all of them are 1 except the last 2. So we have 51s when you're adding the digits, plus a 6 plus a 2. So that looks like 50 plus 8, which is 58. So 58 is the sum of the digits of that big long integer. And therefore, number 22, the answer is D. The sum of all the digits of the integers from 98 to 101 is 9 plus 8 plus 9, 9, 1, 0, 0, 1, 0, 1, which is 38. The sum of all the digits of the integers from 1 to 2008 is. So we've got a lot of work to do in this question, but let's take it one step at a time, systematically. First, let's just look at 1 to 10. That's going to be 1, 2, 3, all the way up until 9, right? And if you do that, if you add them up, it's just 9 times 10 divided by 2, which is 45. All right? So that's the first one. Now let's look at 10 to 11. It's 10, 11, 12, all the way up until 19, right? Now we're adding, not the numbers, we're adding the digits. Okay, so be careful. First, let's just add up the units digits. That's just 1 to 9. 1 to 9 is always 45. Then you're adding up the tens digits, which in this case are all ones. 1, 1, 1, 1, like that. And how many of them are there? Well, there's 10 of them. So that will be 45 plus 10. Okay? Similarly, if you go from, this was 10 to 19. If you go from 20 to 29, let's see what the pattern is. It'll be 20, 21, 22, all the way up until 29. Again, if you look at just the units digits, that will add up to 45. And if you look at the tens digits, those are all 2's, and there's 10 of them, so it would be 2 times 10, which is 20. Okay? And very similar, you can keep going until we get to 90, 90 to 99. That's going to be 90, 91, 92, all the way until 99. If you add up the ones digits, it's 45. If you add up the tens digits, it'll be 10 times 9, which is 90. So these guys, if you add them all up, how many 45s do we have? Well, we have 9 of them. So 9 times 45. And then 10 plus 20 plus all the way up until 90 is really just 10 times 45. Because if you factor out a 10, it's like 1 plus 2 plus 3 all the way up until 9. And therefore, this is going to be 855. All right, so that takes care of that one. Now we get to the next part, which is going to be hundreds. So let's look at 100 to 109. So we got 100, we have 101, 102, all the way until 109. And then if you're adding up the digits, the units digits will give you 45, the tens digits give you nothing, and then the hundreds digits is all ones, so and there's 10 of those, so you got 10. Okay? And then we got 110 to 119. 110, 111, 112, all the way until 119. Units digits, again, give me 45. But now the tens digits give me all ones. So if I add up those, there'll be 10 of those. And then the hundreds digits are, again, just ones. So that just gives me 10. And then similarly for 120 to 129, this gives me 45 for the units digits. It gives me 20 this time for the tens digits because it's all 2's and there's 10 of them, so 2 times 10 is 20. And then for the hundreds digit, it's still 10. And then ... I'll just jump to the 190s. 190 to 199, units digits 45, tens digits give me 90, and the hundreds digits give me 10. So adding up all of these, I'm going to have how many 45s? Well, it looks like I'm going to have 10 of those, so 10 times 45. And then these guys in the middle, it's like adding 1 plus 2 plus 3 all the way till 9, but you have to multiply that by 10, so it's 10 times 45. And then these guys, that's pretty easy. That's just 10 times 10. So that's 10 times 10 like that. And if you add up these, that becomes 1,000. All right, so I hope you're getting the hang of this. And we continue like this, and I'll let you do, I'm obviously not going to do every single one from all the way up until 2008. So I'll just tell you what the results are. If you do 200s, right, the 200s, 2 to 299, exactly the way I did for the hundreds here, you'll get a sum of 1100, okay? No different. It'll be the same pattern, the same kind of style. Nothing changes. If I do the 300s, I will get a sum of 1200, all right? And so on and so forth. So if I do, I'll just write them side by side. 400s, and I add up all the digits, it'll be 1300, and so on. Now at this point, we have finished with the 900s, and we are now moving into the 1000 plus numbers. But there is a fortunate shortcut to doing that, and I will explain as follows. If you look at this range right here, that was from 1 to 99, right? So once you pass 1000 and you get to the range 1000 to 1099, all the digits, when you add them together, will be exactly the same. The only difference is that the numbers all will have a 1 before them. So it essentially is the same summation, which in this case was 900, but then you have to consider the fact that every number has a 1 in the 1000th column, and there's 100 of them. So those 100 ones, which total 100, have to be added. So when you're adding the digits from 1000 to 1099, it will equal 1000. Okay? And similarly, we can do the same thing for 1100 to 1199 by looking at 100 to 199. That summation was 1000, but remember, each of these guys will have a 1 in front of it. So since there's 100 of them, there'll be 100 ones that you have to take into consideration. So you take this 1000 and you add to it all of those ones. And if you do, you get 1100. Okay? So that definitely helps us figure all of these out very quickly. So instead of having to go through this painful thing all over again, we can just do this very quickly by adding 100. So the 1200s, these were the 1100s. The 1200s, well, let's look at the 200s. The 200s gave us a sum of 1100. So we have to add 100 to that. So the 1200s would give us a sum of 1200. If you want the 1300s, we would look at the 300s, which is right here. And the 300s had a sum of 1200. And again, when you're looking at the 1300s, you're looking at the same numbers, but each number will have an additional 1. So you have to take into consideration that there's 100 ones. So you add 100 to this number. So that becomes 1300. And similarly, you just fill out the table like that. All right, so we're almost done. Our final is going to be 2000 to 2008, right? So I think I can squeeze that in here. So that's going to be 1 plus 2 all the way to 8, and that is 8 times 9 divided by 2, which is 36. And then I've got to add these 2's, and there's 8 of those, or 9 of those. So 9 times 2, which is 18. And that gives me 54. There we go. I've got all my numbers here. So let's add all these up now. I've got 45. I've got 855, 1,000. Then I've got all of these. I've got 1,000, 1,100, all of these. And finally my 54. Adding up all of those numbers, you get a grand total of 28,054. And for this question, that is answer choice E. If the 6-digit number 1 A, B, C, D, E, each letter represents a digit. Given that 1 A, B, C, D, E times 3 is equal to A, B, C, D, E 1, the value of A plus B plus C plus D is. We have to fiddle around with this, and let's see what happens. So, in the standard way that you first learned multiplication, A, B, C, D, E 1. Okay, here we go. So, the first column tells me that 3 times E has got to be equal to 1. Well, all of these are integers, right? Well, they're digits, which are integers, but this is not possible with an integer. So 3E can't equal 1. It could equal 11, but again, it wouldn't work. But when you make it equal to 21, that's when it works. E becomes 7. So that 7 is something that is going to help us. So I'll just put it right below right there. So that's basically representing the value. Okay, let's keep going. So that means 3 times D plus the carry, right? Because 3 times E is going to be 21. So you put the 1 here, but then of course you got to carry the 2. So in that style, 3 times D plus 2 has got to be equal to that E, which is 7. Okay, well 3D therefore equals 5, but that's not possible, right? Because D's got to be an integer. So that means 3D plus 2 perhaps could have been 17, right? So 3D equals 15, D equals 5. That works in terms of an integer. So D equals 5. So I'll put the 5 here, put the 5 here to represent what the value of D is. Let's keep going. And this time there was a carry. 3 times D is 15. And then we had to add the 2, make it 17. So the carry is just a 1. Keep going here. 3C plus 1 is equal to 5. Well, that means 3C is equal to 4. Well, that doesn't work. So 3C plus 1 perhaps is 15. Let's see. 3C equals 14. That doesn't work. 3C 25. 3C plus 1, I should say. And therefore 3C is 24. That works. C becomes 8. Okay, so let's put that in there. C is 8. C is 8. Is there a carry? 3 times 8 is 24, plus the 1, 25. We put the 5 here, and then therefore the carry goes here. That's a 2. Okay, next one would be 3 times B plus 2 is equal to this C, which is 8. Does that make sense? Yeah. 3B is equal to 6. B equals 2. Okay, great. So that's a 2, that's a 2. And I think we just have one letter left. Is there a carry? There's no carry, right? Because it's 3 times 2, which is 6 plus 2. Yeah, so there's no carry this time. So the last one looks like 3 times A, no carry, is equal to 2. Well, that's not going to give you any integer solutions. How about 12? That will give you 4. That will work. So A is 4. And there we go. We got it all. So now we got to figure out A plus B plus D plus C. Okay, so that's going to be 4 plus 2 plus 8 plus 5 plus 7. And that is equal to 26. So number 22, the answer is B. John writes a number with 2187 digits on a blackboard, each digit being a 1 or a 2. Judith creates a new number from John's number by reading his number from left to right, and wherever she sees a 1, writing 112, and wherever she sees a 2, writing 111. For example, if John's number begins 2112, then Judith's number would begin 111, 112, 112, 111. After Judith finishes writing her number, she notices that the leftmost 2187 digits in her number and in John's number are the same. How many times do 5 ones occur consecutively in John's number? So let's try to work with this. First and foremost, we've got John, and then we've got Judith, correct? Now we have to start figuring out what is John's number, and Judith's number will be able to figure out from what is John's number. So for example, if John's first digit is a 2 in the big long number, right? Judith will then write 1, 1, 1, correct? Entirely based on the question. When Judith sees a 1, she writes 1, 1, 2. When she sees a 2 in John's number, she writes 1, 1, 1. Okay? So 2, 1, 1, 1, immediately this doesn't work. Why doesn't it work? Because this sentence right here, after Judith finishes writing her number, she notices that the leftmost 2187 digits in her number and in John's number are the same. So when we write out all these numbers, we have to make them in a way so that they're always the same until we get to the 2187 digits. Now, I'm not going to write out all 2187 digits, but I'm going to try to see if there's a pattern here. So the only thing we figured out from this is that John's first number cannot be a 2. It must be a 1. Because if it's a 1, then Judith will then write 1, 1, 2. And so far, it matches. Okay? So if John's first number is 1, and then Judith writes this, then we then know then John's next number is also 1 and then 2. Why do we know that? Because the numbers always have to be the same for the first 2187. You got it? Okay. I'm just going to do a few of these. So here we go. All right, so here we go. So the first one is a 1. And we go on from there. Remember, this is John, and these numbers are Judith. Okay? So just top row is John, and below that are Judith's numbers. Okay? So entirely based on what the question told me, if it's a 1, it becomes 1, 1, 2. And if it's a 2, it becomes 1, 1, 1 for Judith's way of writing it. All right? So I'm just going to keep going in this way, and I'm going to write out a lot of them, and then I'll come back and I'll explain what's going on. So here we go. For John, I've written out quite a few, and I've also written out quite a few numbers for Judith. And I'm not going to write out all 2187, but I did write out 81 digits for John and 243 digits for Judith. And I did that to illustrate a certain pattern. Starting from the very beginning, his very first number, 1, and therefore Judith writes 1, 1, 2, right? That's the rule. And then since Judith's first 3 numbers are 1, 1, 2, that must be John's first 3 numbers, because the first 2187 digits for both John and Judith must be the same. So John has a 1 for the second digit, so therefore Judith again writes 1, 1, 2. But his third digit is 2, so when she sees a 2, she writes 1, 1, 1. And this pattern just keeps on going, right? This system, this rule. And that's what I did. These top numbers are all John, all these guys are John, and the numbers below them, those are all Judith. Okay? Now, what do they want in our question? What is it that they want? They want you to figure out how many times do you have 5 consecutive 1s? All right, well, let's figure it out based on what I wrote. 5 consecutive 1s. Okay, I see this is one scenario. That's 1, 2. This is for John, right? Not for Judith. So I've got 3, 4. Any more? 5 here. 6. 6, and it looks like it's the start of another one, but we only have 6 full ones. Okay? It doesn't give me too much help, but it sort of gives me an idea. That means when I've written 81 digits for John, I get 6 times where you have 5 ones. Okay? Now let's look at Judith. Judith, I've written out 243 for her. So it should be more, right? It should give us a better idea. Okay, let's see here. 5 consecutive ones. There's 1, there's 2, and there's 3, there's 4, 5, 6, and then this one is 7. Do you see how that's 7? Because it's 1, 1, 1 here, but then it's 1, 1 over there. See, I wrote it sort of like one on top of the other, but if this was all written out in one line, that would be 5 consecutive ones. So don't miss that. And then what we're up to here, 1, 2, 3, 4, 5, 6, 7. So this is 8, 9, 10, 11, 12, 13. Again, 14, okay? 15, 16, 17, 18, 19, and 20. Okay, that's a good number. So for 243 digits, you get 20 times that you have 5 ones in a row. All right, so at this point what I did is I said, well, Judith's first 243 digits are the exact same as John's. Judith's first 2187 digits are going to be the same as John's. So if we have 20 in 247, then perhaps it will be the same in terms of a ratio for 2187. Well, let's see. 2187 divided by 243 is equal to what? Well, it's equal to 9. So for each 243 digit series, you'll get 1, 1, 1, 1, 1 appearing 20 times. So that means since this is 9 times the length, it should be 20 times 9, which is 180. I hope you understood that. And then I went back to see the answer choices, and 180 is not one of the answer choices. So I thought, oh no, what do I do here? What did I do wrong? And the answer is I didn't do anything wrong. This is definitely part of it. You will get 180, but you'll get a few more. Why will you get a few more? Because eventually a couple more will pop up. Because eventually the key to understanding this question is that you get to a scenario like this, where you'll have ones at the very end. And when you match that with the next series, it joins to become one full 5-1 sequence. So that's a tough thing in this question. I really wish the answer was 180 so I could just circle it and move on with my life. But the fact that it's a few more than 180 is what makes this question difficult. And that's the part I have to explain now as to how many more than 180 are there. So to explain that, I've got to make a little bit of a table. So here we go. So I wanted to keep John and Judith's numbers, at least the first 81 digits for John and the first 243 digits for Judith in the screen. And then this table is going to be as follows. The first step, the length of each step, and then how many ones do we have in that step, how many twos do we have, and then what does that step end in terms of a number? Does it end in 1 or 2? And then how many of those 1, 1, 1 ones do we have? What we're interested in. All right. So step number 1 is my very first one. Well, the length is just 1 digit, so that's 1. How many ones do I have? Well, it was just 1, so I have 1, 1. How many twos? Well, 0. It ends in a 1. And how many of these 5 ones do I have? Well, none yet. The next one is my 112 right here. Now I can use John's or Judith's. I'll use Judith's because I've got so many more of hers. It's easier for me to look at that. So this is my step number 2 when I go to the next step, right? And this time, that 112 is step number 2, and the length is 3 now. Okay? 112 obviously is 3 digits. How many 1s are there in 112? Well, there's 2. How many 2s are there? Well, there's 1. And does it end in 1 or a 2? It ends in a 2. And how many of these 5 1s do I have? Well, 0 so far. Now the next step would involve 9. And it's these 9 right here. These guys right here. 112, 112, 111. Okay? So for those, that's the next step. It's a length of 9. How many 1s do I have? 1, 2, 3, 4, 5, 6, 7. How many 2s? 2. It ends in a 1. And how many of those 5 1 strings do I have? Well, none. It starts off with 1, like it's part of 1 is there, but there's no full 5 1s in a row. So the answer is 0, but in brackets I'll put like a half just to show that a part of it is beginning. All right, let's keep going here. Fourth step would involve 27 digits, so it's basically all these guys, these 27 numbers. And that would mean the number of 1s, oh boy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the number of 2s, 1, 2, 3, 4, 5, 6, 7. It ends in a 2, right? Because this is the last digit, it's a 2. And how many of these, now, how many of these 5 1s do we have? We've got 2 of them. We got 1 here, and we got 1 there. So finally, we have a few full ones. And then you just continue like this. But you say, well, okay, I understand that you're multiplying by 3 every time. So when you get to 81, it's going to be this whole, all of these, that's 81. But you really expect me to sit there and count all the 1s? And the good news is you don't have to. Here's a trick. The number of 2s is going to be the same as the number of 1s from the previous step. Let me repeat that. The number of 2s will be the same as the number of 1s from the previous step. Why? Because whenever you had a 1, you remember in our system, whenever Judith saw a 1, she made a 112 in her step. So every time there's a 1 in the next step, there's going to be the same number of 2s. So that means that the number of 2s at each step equals the number of 1s from the previous step. So using that very important piece of information, we can fill this in a little bit more quickly. Here, it's going to be 20, because the number of 2s at each step equals the number of 1s at the previous step. And therefore, since the length is 81 and 20 of them are 2s, the other 61 must be 1s. So that's just a subtraction. This one, have I got 81 in a row? Yeah, I got 81 in a row. So the last one is right here. It's a 1. Okay, and then how many of these 5 1s do we have in a row here? Let's see. 1, 2, 3, 4, 5, 6. 6 and a little bit of the 7th. So I'll put 6, and then I'll put sort of like 6.5 in brackets just to show that there's one that's about to start right here. You notice this one here? Okay. 7th step, again, multiplying by 3, 243. The good news is we do have the full 243 written out, and that's all of these guys. This one, and this one, all of Judith's basically. So the bottom rows. And that one, okay, I'm certainly not going to expect you to count the number of 2s, but you don't have to. It's the number of 1s from the previous row. So there you go. And this is just a subtraction now, 243 minus 61, which is 182. Okay? And then this ends, the very last one was a 2. And then how many do we have? Okay, this is the big one here. So we got 1, 2, 3, 4, 5, 6, 7, right? 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I remember we had actually figured that out earlier, that it was 20. So put that in there. So this is 20, a full 20. Okay, now bad news is that for the next step, I actually don't have it all written out, and I'm not going to write out 729 of these. But we can use the system to figure out what these numbers are. Well, the number of 2's is the same as the number of 1's in the previous row, so this is 182. 729 minus 182, it's a subtraction question to get the number of 1's. This ends, well, by this point, it's 1, 2, 1, 2, 1, 2, so I'm pretty confident this is a 1. But this is the question right here. Well, it's 3 times the number of digits, right? This is 243, this is 729. So you would think it's 3 times 20. Okay, but here's the thing. The answer is 60, but because it ends in a 1 right here. That means when you get to the final, it's going to look something like this right there. It ends in a 1, so it's going to be part of the next 1, 1, 1, 1, 1, 1. So I'm going to put a little half like that. Does that make sense? I hope so. So, because that's the heart of understanding this question. That's how we're going to end up with more than 180. Remember, I got 180 before, but that's not one of the answer choices. All right. Hopefully the last one will put it all together. The last step is when you get to the full 2187. Remember, the number of 2's is the same as the number of 1's in the previous row. And then to get the number of 1's, you just subtract 2187 minus 547 is 1640. This is going to end in a 2. And this is the heart of our question in terms of our answer. What is that answer? Well, I previously got 180. Okay, this is where you get the final answer. So, here we go. Pay close attention now. For a string of 729, right, you have 60 of these 1, 1, 1, 1, 1, 5 ones in a row. For the next 729, again, you'll have 60. And notice what I'm doing. I'm putting a little bit of a half in brackets. And then for the next 729, you'll have 60 like that. Okay? 60 plus 60 plus 60 is 180. But there's these halves. And what does those halves represent? Do you remember? In my, diagram, they represent sort of 1, 1, 1 at the very end. And that will join with a 1, 1 at the beginning of the next string to create a 5 consecutive 1 sequence. So each of these will give you a 1, 1, 1, and then it will join with the 1, 1 from the next one. Does that make sense? And then similarly, from the next 729, it will be 1, 1, 1. It will join with the first 2 ones in the next sequence. And that's how you end up getting 2 more. So the final answer is 180 plus 2, which is 182. And that is the answer to this question. So I will admit this is difficult because I got 180 and then I couldn't figure out for the life of me how you could get more than 180. And I had to go through this entire system in order to get the final answer of 182. So it's difficult, but if you have some sort of a system, you should be able to figure this out. So number 25, the answer is A.